How are you doing? This is Mike Johnson again, and we are here, and we're going to discuss a continuation to the quadratic equation. And in this video, we're going to discuss how to solve this using a formula. So we can solve the quadratic equation when it's set equal to 0, and it falls in the form of ax squared plus bx equals to c. And we can use a formula called the quadratic formula. And the quadratic formula falls in the form of x equals to negative b plus or minus the square root of b squared minus 4ac all over 2 times a. It falls in that form of negative b plus or minus the square root of b squared minus 4ac all over 2 times a, where a is our leading coefficient, our b is the coefficient in front of the x, and the c is the constant. So let's go ahead and see how we can apply this quadratic formula. So let's say I want you to solve the equation f of x not 0 equals to x squared minus 5x plus 6. And you might say, I want to try factoring this, and that's a valiant attempt, and that's a valiant way to tackle this problem, and you would get x minus 3 times x minus 2, and you could use that zero value theorem to set each one of these equal to 0. So you would get x equals to 3 and x equals to 2. Now, if you wanted to use a more formalized process, well, not that factoring is not formal, but a formula method, you could recognize that your a value here is a value of 1, your b value is a value of negative 5, and your c value is a value of positive 6. So all you would do now is plug into your quadratic equation using those three terms. So you would have x equals to negative 5, because you have that b, which is a negative 5, so you have to plug that in using a negative 5, plus or minus the square root of b squared, which is the value negative 5 squared, the quantity negative 5 squared, minus 4 times a, but a is 1, times c, which is a value of 6. And this is all underneath the square root. And this is divided by 2 times a, but again, a is equal to a value of 1. Continuing, we're going to get x equals to negative 5 gives you a value of positive 5, plus or minus the square root of 25, because negative 5 squared is positive 25, minus 4 times 1 times 6 gives you a value of minus 24, and this is all over a value of 2 times 1, which is a value of 2. Notice that we can simplify that radically even further, and we're going to get x equals to 5 plus or minus the square root of 1 all over 2, and the square root of 1 equals to 1, so we get 5 plus or minus 1 all over 2. That plus or minus will indicate two different solutions. So we're going to get x equals to 5 plus 1 all over 2, and x equals to 5 minus 1 all over 2. So we get 5 plus 1, which is equal to 6 over 2, which is a value of 3. And this is equal to 4 over 2, and we get the other value of 2. So we're going to get the same exact solution whether or not we factor or use the quadratic equation. Both of them are formal processes. One just uses a formula, the other one uses factoring. So let's go ahead and see if we can apply that to another example. Let's go ahead and apply this to another example. So let's say I want us to solve, and this will be, the instructions will state to solve, x squared plus 5x plus 8 is equal to 0. X squared plus 5x plus 8 is equal to a value of 0. So let us go ahead and not try to delay. We want to first analyze a couple of venues. I always like to check if I can factor first, because if I can factor rapidly, I'm all about factoring rapidly. But notice, there's no factors of 8 that add together to give you positive 5. So I know that in order for me to solve, I'm going to have to use the quadratic equation. So here, my leading coefficient a is equal to 1. My b value is a value of positive 5. And my c value is a value of positive 8. So I try to get in the habit of putting the signs there just so I don't make a mistake and forget them. But again, that's your discretion if you like to. So now I always write my quadratic equation, my formula down. That way I don't forget it and I can use it rapidly. So we have negative b plus or minus the square root of b squared minus 4ac all over a value of 2 times a. Continuing, I'm going to plug in. So I have negative b, but my b is a value of positive 5. Plus or minus the square root of b squared, which is positive 5 again. But I'm going to put that in a set of parentheses just to make sure I don't forget. Minus 4 times a, but a is a value of 1, times c, which is a value of positive 8, all over a value of 2 times a, which is a value of 1. Notice here we're going to get x equals 2. Negative 5 plus or minus the square root. Simplifying, we're going to have 25. Negative 4 times 1 times 8 gives you a value of negative 32. And this is all over a value of 2. Simplifying even more, we're going to have x equals to negative 5 plus or minus the square root of 25 minus 32 gives you a value of negative 7. This is all over 2. But I want to write this in a more formalized manner, so I'm going to get rid of that negative, and I'm going to write that in terms of imaginary value I. So I have negative 5 plus or minus I root 7 all over 2. So this indicates that we're going to have two solutions. We're going to have our first solution at x equals 2, negative 5 halves plus I over 2, plus root 7 all over 2i. And then we're going to have x equals to negative 5 halves minus root 7 all over 2 all times I. So in this circumstance, we have two imaginary solutions. So this is a great circumstance that shows us that we had to use the quadratic equation in order to solve this because there was no easy way for us to factor that. The quadratic equation is a great tool. Make sure to try to commit it to memory. It does make this much easier.